Hi there, welcome to your lesson on sigma notation. If you're not sure what that means, sigma notation is a way of writing some things in mathematics using this symbol here. If you've ever seen that symbol, that is the Greek letter sigma, and its meaning in mathematics is sum. So let's take a look at some examples of that. Okay, so here we go. So again, here it is. This symbol here, this is the Greek letter sigma. It is called the summation symbol. Something didn't print properly here, but anyway, the summation symbol. Okay, so examples. Here we have this example. And usually with summation, we'll have something on bottom and top. And those things on the bottom and top tells us from what value to what value we're going to find the sum of. So when we see this here, it means we're going to take the sum of I from I equals 1 to 7. That means you replace this with 1, and then you do a sum. So plus, then you replace it with 2, plus, then you replace it with 3, plus, all the way until it's 7. So the sum of that. So this means find the sum of I for I values from 1 to 7. So this one here, the same thing. It means find the sum of 3n plus 1 for n values from 1 to 5. So that means you will put 1 in here, get a value, plus put 2 in here, get a value, plus keep adding until you've gone all the way up to 5. That's all that symbol means. Okay, so for example, let's say we had this function here, or this sequential rule here, u sub n equals n minus 3. The first three terms, what would they be? So if you put 1 in here, 2 in here, 3 in here, what would you get? Well, the first three terms in the sequence are -2, -1, and 0. Now, we can turn that sequence into series notation, and we talked about that in the previous lesson. A sequence is like this, all the terms, one after another in a sequence. We turn a sequence into a series just by adding those. So as soon as we say we want the sum of those, it is a series. And now we have this symbol called sigma notation that helps us write a series. So this series can be written like this. Okay, these numbers are generated by this rule, and we want to find the sum here of the 1, 2, first three terms. So n equals 1 all the way through 3. That's how we use that symbol. So now let's try it here. We have another sequence here defined by this rule. Find the first three terms. So put 1, 2, and 3 in here. There's our first three terms. This is a sequence. Turn that into a series by adding those terms, and then write it in sigma notation like this. So we need the sum of this rule with n going from 1 to 3. That's exactly what we see here. N is 1, n is 2, n is 3. We want the sum of those three. So it looks kind of strange, but once you understand what it's doing, it's not that complex at all. I hope you can understand through this example. Let's go a little further with this one. So here it says, write this expression as a sum of terms. So here's that rule we're given right here, this summation, and it says I equals 1 through 4. So make this 1, make this 2, make this 3, make this 4, and then add those things up. So what do you get? Okay, so when I equals 1, we put a 1 in here. What do we get? We get 2 times 1 plus 3, right? And then this says sum here. This symbol means sum, so plus, when I equals 2, we put a 2 in there. So 2 times 2 plus 3. And then plus when I equals 3. What's the next thing going to be here? Okay, when I equals 3, we're going to add 2 times 3 plus 3, right? 2 times, this becomes a 3. And then finally plus when I equals 4, because this goes up to 4. So plus, and I becomes 4 here, and we have that. So now that's the expression for the sum of these terms. You can, of course, simplify those into 5 plus 7 plus 9 plus 11. And you can tell this is a arithmetic sequence, and we can see that from the rule also, because the rule looks linear, right? This is like our slope. This is like our y-intercept. So the slope value is our common difference, and we can see this goes up by 2 every time. So this is definitely a linear or arithmetic rule here, and we can see it here. And now we're showing the sum because this is sigma, so it's a series. Now calculate the sum. Okay, add those up, 32. So the result of this is 32 because it just means do the sum of the series like this. Pretty simple if you just break it down. All right, let's look at this. Oh, and let's not forget that this connects Yes, we're using this symbol now to talk about sum, but in the last lesson, we did talk about sums of arithmetic sequences, and we had this rule. So let's just confirm that this rule produces the same value. If we use the sum rule, we want the sum of how many terms? Well, we did the sum of 4 terms here, 1, 2, 3, 4. Sum of 4 terms, this will be a 4. This will be term 1, which is 5. This will be term 4, which is 11. So 5 plus 11, 16 times 2, 32. It produces the same answer. It's important to make these connections as we go, as we look at things from different perspectives, to remember that they're connected. So this notation is connected to the summation formula we already had. Okay, so try this. Write this series using sigma notation. How many terms do we have? 1, 2, 3, 4, 5, 6. So the way to start is say, hey, I need a sigma, because it's a summation, from n equals 1 through, well, n equals 1 through 6, because there's 6 terms. We're taking the sum of the first 6 terms. And then you need to figure out what the rule is that goes here. So what rule would create this? So look at this and say, hey, is it arithmetic? Because we know how to make arithmetic rules. Is it? It's definitely arithmetic. U1 value of 1 and a common difference going up by 2 every time. So there's our common difference. So if we have U1 and D, we can use the UN rule to create a general rule for this arithmetic sequence. What is it? So UN equals like this, right? Put in U1, put in your D value. Maybe simplify this by multiplying both of these by 2. And you get that, there it is, 2n minus 1. So therefore, our sigma notation for this one should be n values 1 to 6, and then this rule, because that rule produces these values. As simple as that. And again, don't forget that that really means the sum. It's the same thing, summation formula. Great job. We'll see you soon.